Hello, welcome. We're going to go ahead and take a look at a speed word problem with some tips and tricks that you can use for all sorts of problems that will just make it much easier to set up these problems and solve them. So let's just jump right in and take a look at a sample problem. Lucas walks to a store at a speed of 4 miles per hour. The store is 0.8 miles away. How long does it take him to get there? Express your answer in minutes. So when we read this problem, we have to sort of collect what we know and then also make sure we can figure out what we're solving for and then be efficient in our way of getting to the answer. The first thing that jumps out at me are the numbers. It tells us there are 4 miles per hour. And while it might be tempting to leave off the unit, in speed problems, you really don't want to do that because that will frequently make it a lot more difficult. Oh, just realized that I was mirroring the camera. Let's see if we can get it a little bit bigger here. There we go. Okay. All right, so we've written down our speed, miles per hour, 4 of them. And then that is our speed. I like to collect it. And then the other number that I see is 0.8 miles away. That tells us how far away it is, so that is going to be our distance. Now the one thing I look for, and the reason it's so nice to write down those units, is I'm comparing the two distance units. They're both miles, and that's great because the problems get much harder when the units don't match for the type of unit that it is. And then it's asking us how long does it take him to get there. Anytime you're asked to figure out how long something takes or at what time something's happening, they're looking for an answer having to do with time. And then we can make a note of that too. That's what we're looking for, so I'm going to collect it here, t equals question mark. Now, the one thing to note is it says express your answer in minutes, and our speed was given to us in hours. So I'm going to make a note of that my final answer should be in minutes. But if we are just going to use the formula for speed, we would get an answer in hours. So the units you put in are the units you're going to get out. So if we're going to put miles per hour into our formula, then any time that sort of comes out of that formula will be in hours. So we would have to convert at the end. However, there's a quick and easy way to do this if we set this up as a ratio. And this is a great strategy to use for all speed problems because it allows you to pull apart the sort of hidden information inside the speed unit that was given to us, and it's a great way to be able to check your answers as well. It's always good to sort of see, does something make sense, and setting it up as a ratio like this will make that much easier to do. So all speeds are comparisons between distance and time. So I'm going to go ahead and just set that up here. I'm going to use D and T because we've done so many of these problems with distance and time that D and T will always stand for distance and time. So let's break down that speed unit. It is 4 miles per hour. That means 4 miles in every 1 hour. So the 4 miles are just going to go under distance here. If you don't have room to write your entire units, just abbreviate, but do keep it in there. And then that's in 1 hour. So we have 4 miles in every 1 hour. Well, that's great. Our speed is now broken up into these components of distance and time. But we don't want to know how long it takes to go 4 miles. We actually would like to know what's the time that's associated with 0.8 miles. So now we have to sort of use everything we know about fractions and simple operations to make some adjustments here. Now this is a great time to get our units to match. 1 hour is equivalent to how many minutes? Well, that's really just equivalent or equal to 60 minutes. I'm going to write that behind here. I can just replace that 1 hour with 60 minutes. In addition, I'm looking at 4, I'm looking at 0.8, and I'm reminded of my multiplication multiples of 8. 4 can be multiplied by 10 to get 40, and 40 is divisible by 8, which means 4 is also going to be divisible by 0.8. And if you don't recall, just remember that 4 divided by 0.8 is equivalent to 40 over 8, which is going to be 5. So 0.8 fits into 4 5 times, which means we can go from 4 miles to 0.8 miles by dividing by 5. Now the 1 hour wasn't going to easily divide by 5, but our 60 is going to easily divide by 5. 60 divisible by 5 is 12. So we figured out something we can do to both sides of our ratio, the 4 miles and the 60 minutes. Both of them can be multiplied, or, well, in this case, divided by 5. And as long as we're doing the same thing to both sides, we still have an equivalent ratio. And so 0.8 is going to be equivalent to 12 minutes. And we actually have our answer right here. It is going to take 12 minutes to go 0.8 miles. It takes 12 minutes for Lucas to travel that's 0.8 miles. Now before we're going to be done, we need to double check. Does this make sense? Well, 0.8 is a lot less than 4 miles. If I'm looking at it, it's 1/5 of the total distance. So it needs to be about, it needs to be 1/5 of the amount of time that it was taking for that 4 miles. Therefore, we're looking at 1/5 of an hour. And if we look back over here, we had an answer of 12 minutes. 12 minutes is in fact 1/5 of 60 minutes. It is that 1/5 of an hour, so we're good. Now, if you prefer to use the formula, we need to know what the formula is for time in terms of speed and distance. Well, if you want to know how long something takes, it is the total amount of what you have to do of distance divided by the rate. In this case, the rate is speed. Now, when we plug in, our distance was 0.8 miles. Our speed is 4 miles per hour. And now we're looking at a lovely decimal combined with fraction problem. And recall that the fraction bar is nothing more than a different version of division. So we have 0.8 miles divided by 4 miles per hour. I'm going to write that as a fraction within a fraction here. And so we can use keep, change, flip. So we have 0.8 miles per hour multiplied by the reciprocal, which is just hour over 4 miles. And again, you can do this whole thing by leaving out your units, but I like keeping them in there because you can sort of see how everything works out just so. Now, if we're going to be multiplying with fractions, we can give our 0.8 miles a denominator of 1. Now we can cancel out things. Miles cancel with miles. We're just left the hour on top, which is slightly problematic, as you recall, because we want our answer in minutes. But let's just keep going. So now we have 0.8 over 4 hours. That simplifies further to 0.2 hours, since 0.8 divided into 4 equal parts is just 0.2. And now the final step is turning 0.2 hours into minutes. Now, every hour is equivalent to 60 minutes, so I can just replace that unit of hours with 60 minutes. And we're looking at 0.2 times 60 with the unit of minutes. Now 0.2 is 1/5. 1/5 of 60, as we had earlier, is 12 minutes. So same process, slightly more work. You can see that by setting it up as the ratio and keeping your information in there. We're doing the same kinds of calculations, but there's way fewer steps and less manipulation. So we got to our answer. It takes Lucas 0.8 miles to travel. I'm sorry, it takes Lucas 12 minutes to travel this 0.8 miles. And it's always a good idea to just reread the problem one more time. Did we include all the right numbers? We had the 4 miles per hour we started with. We have the distance, that was 0.8 miles. And we did answer the question of how long it takes him, and we expressed our answer in minutes. So we're good to go. Now, if you would like more problems like this, you can go ahead and visit us at coolwithmath.com and follow us for more simple math that makes sense.